Here's a recap of our lesson on gathering like terms. So when you gather like terms or collect like terms, what you're really doing is you're just adding or subtracting all of the like terms together and simplifying the expression. So I think that you'll find that fairly straightforward. But let's go through it just to give you a little bit of experience in knowing how to work through these problems. So in this particular example, the first example we're going to look at, the question says simplify. So what you need to look at here in the question is if there are any like terms. And so one suggestion that I often have to students is that you may want to highlight or box in like terms in the same color. So I've got my green highlighter here, and so I see that I have a 3x. A 2 is not a like term because it doesn't have the same coefficient and variable. But the next term is a plus 4x. So I'm going to also highlight it in green. And then my final term is a plus 9. And so I can see also that I have a couple of constant terms that are like terms that I can highlight together in the same color. So notice that each time that I'm highlighting these values along with the sign in front of them, because the sign in front of them really tells me whether the number itself is positive or negative. So that needs to travel with the term itself. So now let's write some of this down. So if I want, the next step is to group my like terms. So I want to group my like terms, and that will allow me to quickly see how to simplify them. Once you do this a little bit more, it may not be necessarily to do this second step, but it is helpful, particularly when you're starting, so that you don't make any mistakes, and especially with negative numbers. All right, so I'm going to first just write out my 3x here, and I'm going to also write out the next like term, which is my positive 4x. So positive 4x means that I'm adding 4x in. And so what I've done in that step is I've just taken my like terms and just kind of put them along just in a group together. So here they are. Here's my little bit that I had in the question above, highlighted in green. And then next I want to take any other like terms and group them together. Notice that I put the x terms first and I'm putting the constant terms last. And that's how we typically format algebra and math. We start with the terms with the highest exponent and put those first, and then go down by decreasing exponent. So the next terms that I have are this plus 2, so I'm going to put that next. And then I also have this plus 9 over here, so plus 9. So now I'm ready to go ahead and simplify this whole thing. Here's my plus 9 and my plus 2. Just about done, ready to complete this final step. So now I see that I have 3x plus 4x. That's going to give me 7x in total. So notice that all I'm doing is I'm just adding the coefficients and keeping the variable exactly the same. Think of this like if I have 3 apples and then I add 4 more apples, then I'm going to have 7 apples. Now let's look at these constant terms. So if I have positive 2 and then I add 9 more to that, that's going to give me positive 11. And so there, now I'm done. I can't add a term with an x in it to a term with an 11. Those are not like terms, and so that tells me that my question is done. All right, so let's try another example here. I'm going to start by highlighting any like terms that I see. So when I look at this, I can see that I have 7y, and I also have a positive y. So when I see that, immediately, when I see the positive y, I don't want to forget that that means that I have one y. So I make it a point of sort of writing in a 1 there, and that helps me to remember that little piece about that. So now I can group my like terms. If you want, what you can do is you can write any like terms together right away on a separate line, or you can highlight all the like terms in different colors and then group them after the fact. It doesn't really matter which way you do that. So I know that I have 7y and then plus y, and it's plus y again because I have positive 1y. All right, let's look for some other like terms. I have this negative 8 right here. And that's a constant. And I also have negative 1. Those are like terms because neither of them has a variable. So I'm going to group those as well in the second line. So I'm going to write in minus 8 and then minus 1. And again, the highlighting is optional. You really don't need to highlight. It's not necessary, but it may help you to see the solution more clearly. So, this is where all the green stuff in my first step went to. And here's where all the purpley pink stuff went to in my second line. That's where those terms ended up. So now I've done all the hard work. Now I just need to simplify this. I need to clean it up where possible. So I have 7 y's plus 1 more y, and so that gives me a total of 8y. Then I see negative 8, take away 1 more 8, and that gives me negative 9. And in class we discussed how if you're struggling with managing integers, you may want to double check using your calculator that in fact you've added or subtracted those integers properly, just to reduce the possibility of you making an error with your integers. So here's the third example. It's a little bit trickier. Not so much so. We're seeing though that in this case that every term has a variable in it as opposed to the last couple of examples. So it's important to remember that terms can only be considered like terms and be combined if not only do they have the same variable, but also the same exponent on that variable. So I can't add an x squared with just a plain old x because they're not considered to be like terms. So I'm going to start by taking a look at any like terms that I see. So I've got this positive 9x, just showing you a different way to do this. And I've x squared, that is, positive 9x squared. And I've got this minus 5x squared here. I've also got a couple of other like terms. I've got positive 6x, and that's also a like term with my negative 3x. So now I'm ready to simplify, or group rather, in my next line. So I've got 9x squared, and then I've got minus 5x squared. Those I can combine because they have the same variable and the same exponent. I'm doing the best with my writing here. I don't have my writing pad with me, so please bear with me. Next I have this positive 6x. So I'm going to say positive means plus 6x. And then I've got this minus 3x. So don't forget that the sign in front of the value tells you whether you're adding or subtracting that number from the previous one. Good, so just about done. All I need to do now is just to combine my terms. So 9x squared, take away 5x squared is going to leave me with 4x squareds. Now I've got to add my x terms. So I have 6x, and I want to take away 3x. That's going to leave me with positive 3x. So that means I'm adding in 3x. Tout fini. So here's a final example. about combining like terms. So I'm going to go back to my highlighting method because I just prefer it. I just feel it's a little bit more clear. So, but that, it's completely your choice. You may not really feel the need to highlight at all. I'm seeing here that I have an a squared term and I also have another a squared term here. So I'm highlighting them as the same color. And I've also got some a terms here. So I've got plus 2a and I've got a negative 7a. Now I'm ready to group them. So here we go. So negative 3a squared. Again, don't forget that negative in front, right? And I've got minus 8a squared because the 8a squared happens to be negative. So that sign gets carried along. Now I'm going to go ahead and grab my other like terms. So my other pair of like terms. So plus 2a. And minus 7a. Just quickly going to highlight that for you just to see and make sure that you understand where everything ended up. So my minus 3a and my minus 8a squareds are grouped together now, and so are my a terms here. Final step is, of course, to just simplify if possible. And by the way, it's not always possible. Sometimes there's only one of a particular term and you can't simplify any further, so you just kind of tag that on to the end. All right, let's look at our integer situation here. So I'm starting at negative 3a squared, and I need to take away 8 more a squareds. So, I think, again, in some previous videos I've discussed how thinking about it in terms of temperature can be really helpful. So if it's negative 3 degrees outside and I know the temperature is going down by 8 more degrees, that means it's getting colder. It's going to get colder than negative 3, and so it's going to give me negative 11 as a result. So negative 11a squared. Now I have positive 2a, take away 7a. That gives me negative 5a. And again, like I said earlier in this video, if you feel the need to use a calculator to verify some of your integer calculations, by all means, go ahead and use that calculator to double check. Question done. Can't combine my a squareds with my a, so I am all done. Hope you found the video helpful. I'm going to try to find your